This is Mrs. Palmerquay with the fourth video for Module 3. In this video, I want to talk about classifying and naming compounds. Let's first remind ourselves about classifying the elements. Several videos ago, I talked about how the two categories that you want to make sure you have well memorized are the metals and the nonmetals, and where to find them on the periodic table. Remember, on your periodic table in your textbook, there is a thick line here, sort of stair-stepping down, and that divides the metals on the left from the nonmetals on the right. And that hydrogen needs to be moved over whenever you're thinking about whether it's a metal or nonmetal, because it really, even though it's residing on the left-hand side, should be counted as a nonmetal on the right. So have this big division in your head. Know that here are your metals, and over here are your nonmetals. It will solve a lot of problems in naming compounds if you can keep straight which side of the periodic table these different elements come from. I want to talk a tiny bit about atomic structure, even though this is not mentioned in your chapter. We'll get to it in a later module, but I think it's helpful to know a few things before we get into this topic. An atom is basically made with a nucleus and an electron cloud. Inside the nucleus you have positive protons and no charge neutrons, and around them you have negative electrons. They tend to be drawn with these, sort of orbits going around, sort of like a solar system, but in actuality the best we can figure is that the electrons there's a mush of electrons like a cloud formation around the atoms. The number of protons determine the element. So carbon will always have 6 protons. If a number of protons change, then you have a different element being formed. And that does happen sometimes with radioactive elements. The electrons, however, are not so important because they can be pulled from one atom to another. And in fact, this ability for electrons to be pulled away is what gives us some of the bonds that we have between atoms. So the protons determine what the element is, and the electrons there help neutralize the charge, because in a neutral atom there's the same number of electrons as protons, but the electrons are not as tightly tied as we sometimes think. They move around all the time. In fact, they move around a lot in the wintertime. That's why we get shocks when we hit the door. We've picked up some extra electrons on the way across the rug. Moving on now to classifying compounds, I want to start with when you have a metal plus a metal. These can be atoms of the same element or atoms from two different elements. These are held together by what's known as a metallic bond. Your book doesn't talk about this at all, but I'm just giving it to you as a freebie. And in a metallic bond, you have electrons that are floating freely between the atoms. They're not tightly bound to any one particular nucleus, but just kind of held there. So the phrase that's used is it's a sea of electrons, and these sort of freely, loosely attached electrons are why metals are so good at conducting electricity, because the electrons are free to move and to move that electric field down the metal wire. When you have a metal bonding with a nonmetal, then you have an ionic bond forming, which makes an ionic compound. The distinguishing characteristic of an ionic compound is that it forms ions in the bonding process, that the electrons actually move from one atom to another to form a charged atom, so that the metals on the left, one element from this left-hand side of your chart will bond with one element from the right-hand side of the chart, such as the sodium and chlorine, sodium chloride we've talked about before, or calcium and oxygen, calcium oxide. Typically the metals become a positive ion and your nonmetals become a negative ion. Here's just an illustration of that electron moving. This yellow electron here actually belonged to sodium, and when it was over here in the electron shell around the sodium, then there was no charge on our sodium atom. It was a neutral atom. But when it's brought in close proximity under the right conditions with this chlorine atom, the electron will move. It'll move into the orbital shell of the chlorine atom, giving this an extra electron and a negative charge, leaving sodium behind with a positive charge. And then this positive ion and this negative ion are attracted just like two magnets are attracted to each other. And they stick together because opposite charges attract. That's an ionic bond. Electrons have moved, and it's the fact that one's positive and one negative that keeps the compound together. When you have a nonmetal plus another nonmetal, so that when the bonding is all happening among things over here on the right-hand side of the table plus hydrogen, then we have a covalent bond, and that forms a covalent compound. And in a covalent compound, electrons are shared. They don't up and move, jump ship to go someplace else entirely, but they are shared between the two atoms. So here's a picture of water. Hydrogen here only has one electron normally because it's got atomic number 1, so it's 1 proton and 1 electron. Oxygen in the outermost electron shell has 6. And we'll talk about this as we go on in the course, but the covalent bonds, the rule of thumb is that atoms are trying to get to a point where they have 8 electrons in the outermost shell, or if they're hydrogen, they just need 2. So they share electrons so that they're happy with 8 electrons. So by oxygen sharing the 2 hydrogen, oxygen 6 have turned into 7 and 8 electrons then around its nucleus, and these 2 hydrogens then each have 2 electrons around their nucleus. And this is a very stable situation formed by the covalent bond of shared electrons. So how do we name these compounds? An ionic compound, remember that's a metal plus a nonmetal. We start with the element number 1 name, which will be your metal. I'll say metal first because that lets you know that you start with that. And you just say the name of that metal. Sodium, calcium, aluminum, another calcium. These are all metals. Then the second part of the name is your element number 2, the prefix. You're going to drop the end off the name of that element and add an ide, an IDE. So chlorine becomes chloride, fluorine becomes fluoride, carbon becomes carbide, oxygen becomes oxide. It's a very simple process, but unfortunately with ionic compounds, the name does not tell you how many there are of each element. And so you have to do some memorization, either of individual formulas or of the charges that these ions form. And we'll be talking more about that as we go along. But just to give you an example of the fact of what do these formulas really look like, and remember when you're making chemical formulas, you need to use those atomic symbols, those abbreviations for the names. So sodium chloride we've talked about already, Na for sodium, Cl for the chlorine or chloride in this case, and it's a 1-to-1 ratio. Calcium fluoride, we've got calcium Ca. Fluorine is an F. Fluoride, for calcium fluoride, we have to have 2 fluorine or 2 fluoride ions there to make a neutral compound. Aluminum carbide, well that's aluminum and it's carbon, but we need 4 aluminum and 3 carbon to make a neutral compound. Calcium oxide is just 1 calcium and 1 oxygen. So that I can write these formulas because I know how many electrons move around in ionic compounds, and you will learn that too as we go along. When we get to covalent compounds, we start off the same way. The first element's name, the second element name, the prefix, and then the IDE added. But we also use numbering prefixes. So covalent compounds in their name tell you what the formula is. Sulfur dioxide, carbon tetrachloride, triphosphorus pentanitride. There's a list of these numbering prefixes that you need to memorize. Some of these words I think are probably familiar to you from math class. Also, if there's only one of the element and it's the first element, you don't have to use the prefix mono. But sulfur dioxide, sulfur and oxygen, there's 2 oxygen. Carbon tetrachloride, Carbon and chloride, there's 4 chlorides. Triphosphorus, we've got 3 phosphorus. Pentanitride, 5 nitrogen. So start working on memorizing those atomic symbols, this list of numbering prefixes, and start practicing putting together names for ionic compounds and covalent compounds. That's all I wanted to cover in this video. You've got a lot of memorization to start on.